Hello and welcome to another video at the Learn2Code Academy, where we're looking at part 2 of Unit 1, Fundamental 2D Video Game Design. My name is Williams and let's just get straight into this video. So what we're going to be looking at the second part of this video is input parsing. Let me just get my slideshow working, up and running. Input parsing. So, an input is an integral part of a video game. It's an aspect that separates it from other static forms of media. Excuse me. For us at this stage, we'll begin by looking at simple inputs into our game and processing it to give some sort of feedback to the player. So, what I have here actually is a little illustration of a concept, an algorithmic or should I say an algorithm of sorts, which is a system, a buffer stack. And what's happening here is that excuse me, I have 12 frames, indexed at 0 to 11, 0 index, and I have a particular input at frame 5, input key D. Now this is the input on the D button of the keyboard at a particular time segment in this discrete section of time, T. And what I'm highlighting here with this algorithm is that there is a leniency window of 5 frames, 1, 2, 3, 4, 5, whereby another input can be parsed against this D key press, and any sort of functionality could be executed in relation or in respect to this behavior. So what am I trying to say here? If we look at the example here of the game concept that this actually relates to, I have here a proof of concept game idea. And it's just kind of a concept demonstration. It's nothing fully created. What we have here, and a quick disclaimer, I did not create the art assets that you see here. I've actually used this particular project in another video of mine, but this particular ninja assets I actually obtained from the internet using my resources as and when. But anyway, kind of moving a little bit ahead for the events. This move button is powered by an event. When I click it, my ninja character moves forward. But what we're really interested in is this space here. We're interested in two things. Firstly, I'm going to draw your attention to the hitbox here and the hurtbox there. So when the hitbox, the red square here, collides with the blue rectangle here, my character should take damage. So you can just take that into account. And I have here an attack button. It's a bit laggy on first press for some reason, but as you can see, as the sprite animates, you also have the hitbox extending out in front of the player. But what we're really interested in is that buffer system I was describing here, the input D press. What I have in code, which I'll show you afterwards, is that there is a command that recognizes a particular string of inputs in which, once executed, you get a particular kind of animation. In this case, it's a special attack. So if I were to write input DDL, so within a particular window of time, it's rather fast, it's 5 frames. So I have to be rather quick. There we go. And as you can see, my ninja character sprinted forward in a special attack. And just as a little bit of an extra, should I say, bonus, I did program the hitbox and the hurtbox to interact with each other. So the ninja will take damage. Right now he's not in range. So if I try that special attack again, for some extra range, let's see if we can do that. As you can see, my ninja enemy character, the grey ninja, he's actually turned kind of into a silhouette. And this just is visual information to tell the user or the player that the ninja character here on the left, which is the greyed out one, has taken damage from the player ninja on the right. So let's hop straight into the code, just so I can demonstrate, I can show you the input buffer as it's implemented within the code in Visual Studio C#. As you can see here, I have a for loop which has some nested if statements. Excuse me. And here, the for loop is actually looping within a range of 0 to 5. And this is our window of leniency in which the nested if statements is going to be looking for the key press of D, D, and L. The special sequence of button presses which initiates the special attack of the ninja. As you can see, a Boolean special attack is set to true upon D, D, and L being the concatenated string of button presses clicked, and somewhere else in the program that this Boolean is checked for true, and then the special animation is executed. So right now the Visual Studio is just getting a little bit slow, so I'm going to actually draw our attention away from that back to the PowerPoint. And so the next part of this video we're going to be looking at is events. So events can be considered to be a response that can arise from some occurrence. Usually, this comes as an implicit call to action within a game or program. For example, a player may press the A button, or in our case, the move button, or the attack button for the ninja. This in turn will make the player character jump, the A press being the sender of the event, and the jump action being the functionality that is triggered. .NET Standard accommodates for these kinds of scenarios considerably well with its event classes within the C# language. So I actually do have prepared just a short demonstration of an event. Hopefully I should be able to show what's going on. Nevertheless, I know Visual Studio has been a little bit slow, so just bear with me. I should be able to scroll down, but what I'm going to show you is that all an event is, or should I say, to implement this feature in C#, as I've already described what an event is at a high level. To implement this in C#, there are a couple ways you can go about it: the manual way, or the kind of designer UI XAML style, which helps a lot by making things automatic. So for the button press of move and for the ninja to attack, I actually set the events on the designer, which means that they are automatically created once I set the property of the event to the button. And I wish I could show. What I'm going to do is probably make a little quick cut. So as you can see here in the XAML design window, this move button has an event move button _ click attached to it. So by clicking this move button itself, it actually executes the functionality of this particular event, which in the code it should expose what's there. If I just click that again, my computer's being a little bit slow. You can also observe in the designer view the attack button is here. And just a quick note, the UI is as decoupled as I could possibly make it for this very simple example. You can't see the ninja sprites nor the backgrounds, and you can only see the hitbox and the hurtbox here. And what this allows us to do, as a little bit of a tangent, a little bit of a side note, is that I am decoupling the relationship between the UI and the logic, which means that I can a little bit more easily build functionality tied to the UI without solely relying on the UI designer view of the XAML window. Because what tends to happen is that if you rely too much on building your UI based on the XAML explicitly, you make a really tightly coupled relationship between the control elements and using the designer view, and it makes it hard to make more, should I say, robust, dynamic functionalities. So anyway, all the move button does is sets this to true, is moving, assigned to true. And if I just find all references, if hopefully Visual Studio will be quick enough to right click for me, what I'm going to do is just expose every part of this file, this main window.xaml.cs file where this boolean is referenced. So that's Visual Studio just going to find that for me right now. I suspect it's in the FPS method which I created, which if it is, I'll just quickly explain that with the FPS, there's a function that I created called FPS something. I believe it's like FPS move or something like that. We should see in a bit. Visual Studio has just been a little bit slow. And what it actually does, it actually functions as an update function, which, if we haven't touched on already, an update function is a recurring functionality at every step of time within the program. So what tends to happen is you will have, and Unity is an engine that utilizes this concept rather well, and it's a concept that you can implement in your own frameworks or engine, is to have a particular function that recursively executes indefinitely, and any sort of function that is, should I say, unpredictable, any sort of function that relies on some kind of evaluation of user input, you can consider putting in an update function, and then you can evaluate that particular precondition that you are looking at, such as a button press, in real time to the player. So we have here an if statement that's utilizing the is moving boolean as part of a precondition. If this is moving and this step is less than 10, then something is to happen. So what I'm trying to say here is if is moving is true, and this integer step, which is -10, which actually represents how many steps forward the animation takes the ninja sprite. If I don't reach the limit of 10 steps and I'm still moving in the moving state, then the sprite of the ninja will update to a forward position. So it will step forward by a margin padding thickness property of +2, post increment +2 on the left. As you can see, the thickness double left, I'm using the left parameter there, plus equals 2. All the rest stay the same. And I increment step. And otherwise, once all the preconditions hit false, then is moving is reset back to false. Step reset back to 0. So in a nutshell, we've just looked at input parsing, and we have also looked at events. Compression techniques, I'm actually going to save and postpone for later down the line, as we look at a little bit more advanced topics of the next succeeding units. So I hope you found this introductory course videos for part 1 and 2 helpful. At a high level, what I aim to do is not to really walk you through C#.NET standard as a language. I'm trying to present to you concepts of designing video games, which entails bringing you higher level concepts and breaking them down with lower level implementations, such that you can grasp these ideas and be able to transpose them with your own frameworks, engines, and whatever you're utilizing to create your games. So hope you found this video useful. Feel free to like and subscribe and keep up to date with the latest of this new video course. My name is Williams, and I hope to see you next time. Bye bye.